Okay, before we talk about the properties, tell me again, what is a logarithm? A power, thank you, it is a power. A logarithm is a power. And when we deal with exponents and powers, we have some rules that we follow when we use operations with the powers, okay? Can anybody name one of the rules, the properties that we use for?
It can't be equal to 1 or 0. Wait.
Yeah, no. Just think about just when you worked with exponents, like operations with exponents.
Can't be negative.
Yeah, no, those are conditions. You're giving me conditions. Tell me the properties, like when we are performing some type of operation with exponents. Like when middle school, these are like the middle school rules.
When it's to the 0 power.
No, yes, that's true. That's true, but that's not what I'm going for. Like, for example, power to a power. What do you do with the powers when it's power to a power? You multiply. Okay. So what are the other ones? Give me another one.
If it's in parentheses.
You add.
Oh. Do we?
Being divided, you
Okay. Thank you. All right, Lexi. When you're dividing and the bases are the same, what do you do with the powers? Subtract. Okay. Then there's one other one, right? What's the other one?
When you're multiplying.
When you're multiplying and the bases are the same, what do you do? Add. Okay. The reason I'm bringing those things up is because those properties, those rules that we use with exponents are the same for logarithms. Okay? Because logarithms are just powers. So those are the properties we're going to talk about today. And the first one we're going to talk about is the power property. Now this is on page 1111 in your book. If you would like to screenshot from your book, go for it. If you would like to try to take a picture of this little screen, you can. Remember, the TVs are only so big. And then I'll go through this one with you, and we'll talk about this power property and what it means and how it works. So let me zoom in on the area that I want to focus on. And that's really this rule. Oh, before we do that, we still have our conditions. Okay, M and B must be positive. B cannot equal 1. So these two numbers here must always be positive, and this can still not equal 1. So the same conditions we had before. Oh, cool. It stayed with it. Here's what the power property really is. If I have a log and the number is raised to a power, I can basically take that power and bring it to the front, and then it gets multiplied by the log. So when we think about power to a power, I have a logarithm with another power into it, so it's a power and another power. I can take it in front and multiply, because with normal exponent rules, power to a power, we multiply. So same thing here. If I take this power that it's being raised to and bring it to the front, now it becomes a regular sized number and it gets multiplied by the log without the power. Okay? That's the power property. Now, let me shrink it back because they give us an example. Here's an example. Our example is if I have log base 2 of 6 to the 5th, it is the same as taking the 5, throwing it in front, and multiplying it by that. This is going to come in handy because we're going to be given what this is. And I realize that on your calculator, you could probably go through and figure out how to come up with this. Eventually, you're probably not there yet. But just to understand that's what that means. If I have a log with something to a power, I can take that power and just drop it in front and multiply it by the log without the power now. Okay? So here's an example that I want to go through. And so what's going to happen in your homework, you're going to be given, this will be like the directions. And then they'll ask for this as the actual problem. So you're going to have to use this to come up with what this value is, okay? So remembering again that logs are powers, on your test, I would have told you evaluate log base 3 of 49, and you would have been like, okay, 3 to what power equals 49? Except you can't raise 3 to a power to get 49. Not an integer anyway. You can, 2 is 9, 3 to the third is 27, 3 to the fourth is 81. So I go from 3 to 4, and 49 is not one of them. So we're going to be doing problems like this to try to figure out what that power is approximately equal to. So again, that's what that means. Log base 3 of 7 is approximately equal to 1.7712, meaning 3 to this power will get me 7. So what we do, since the only property we have right now is the power property, what we've got to do is think, how could I rewrite 49 so that it is 7 to some power? So 7 to what power equals 49? Squared. 7 squared is 49. So what we do is we rewrite the problem. Okay, so instead of writing 49, I write 7 squared. Well, why does that accomplish something for us? What can I do now using the power property? Move the 2, where does it go? In front. Okay, so the 2 just goes in front. It becomes a normal sized number. And notice that I underlined the log base 3 of 7, because here I have log base 3 of 7. Well, we know what log base 3 of 7 approximately equals. So I just go ahead and I substitute that in. So that's how I'm going to use the power property to figure out what log base 3 of 49 is. Now go ahead and try it without a calculator, please. And just try to do it in your head. I want you to practice a little mental math. See if you can do that in your head. 2 times 1.7712. Try to do that in your head, and let's see what you get. Then actually, after you get it, verify it with your calculator. How about that? What did we get? What was our final answer? 3. How many did it in your head and did it right? Good job. I think sometimes that's worth practicing. Now, let's understand what this means again. Okay? Log base 3 of 49. That means if I take 3 and raise it to this power, it should be approximately equal to 49. So test that. So put 3 to the 3.5424 power in your calculator and see if that is close to 49.
Yeah.
What did you get?
48.99.
48.99. That's pretty close, right? So again, if I were to have put this on your test, you wouldn't have been able to get it. There's no way. Because, right? Like, this would take you forever. You could have guessed and checked and guessed and checked and guessed and checked. But the truth is, this is one of the reasons why logarithms is important. It's because we can come up with numbers that aren't nice. Okay? So that's the first property, power property. Let's do one more example with the power property. Okay? So here again, this would be the directions. This would be the problem. Zoom in on it. Let's try. Let's see what happens. Oh yeah, it's stuck together and everything. Amazing. I love this program. It's really good. Explain everything. So what are we trying to do here? What's our first move? What do we got to do first? Turn 2 into 32, or maybe turn 32 into 2 to something, right? Okay. So what is 32? If I wrote using 2 as a base, 2 to what power equals 32? 2 to the 5th. Okay. So this is where you should have started. Log base 4 of 2 to the 5th. Right? So what happens to the 5? Goes to the front. What is log base 4 of 2? 0.5. So then I just substitute. 5 times 0.5 is 2.5. So 4 to the 2.5 equals 32. Okay? Questions about that? All right, that's the power property. You'll get used to that one. That one's the easiest one, I think. Okay, the other properties are a little tougher. And the next one we're going to start with is the product property. Again, page 1108. So go ahead and get that situated in your notes. And then I'm going to break this down a little bit for you and go through it, and we'll show you how it works. First off, like, the problem would never look like this. So this is what the problem would actually look like. It would look like log base 2 of 30. And then you would find factors of 30 and you would split them up using addition. So this is why I talked about the power properties at the beginning. When I'm multiplying exponents that have the same base, you add the powers. So when I have factors that are being multiplied together, you can separate them using addition. Because again, they're just powers. If I add the powers together, that's what's going on here. That's the relationship between the product property of logarithms and then just multiplying exponents. Now, in this example, log base 2 of 30, they happen to choose 5 and 6. Well, I could have also just as easily have said log base 2 of 3 plus log base 2 of what? 10, right? Because 3 times 10 gives me 30. I could take that a step further if you wanted. I could then break up 10. How would I break up 10? 5 and 2. Now I want to focus on this real quick, because oftentimes you're not going to be given something like that. What is that? Evaluate log base 2 of 2. What does that equal? I could have put that on your test.
1.
Why do you say that, Eddie?
Because 2 is 2. 2 by itself is 2.
So 2 to the what power equals 2. So anytime the base and the number are exactly the same, it equals 1. Anytime. And in some of the homework problems that you're going to do today, they're not going to give you that particular one. But you have to know that you can always use it if you want to. And I'm going to show you what I mean here in a minute. Because in this next example, like I gave you log base, what was it? Was it log base? It was log base 4 of 2. Yeah. And then the other one was log base 3 of 7. We gave you those like in the quote-unquote directions. Sometimes they won't give you enough things, and I'll show you what I mean here. Okay? So whatever factors you choose to use of this number, you can split them up using addition. Okay? So here's another example. So here's what I mean. Here are the directions, and this question has come up 2 periods in a row. This is the problem. It's like, this is problem number 1 in your book. There it is. Here are the directions for this problem. So for those of you wondering where the log base 4 of 75 is, that's the example problem, okay? You want to write those directions down, because those directions are what you're going to see in your homework today. These directions tell us that log base 4 of 3 is approximately equal to 0.7925. Log base 4 of 5 is 1.1610. So here's what I have to do in this problem. I have to rewrite 75, and I'm going to ask that you use multiplication. Somehow with 3 and 5, you've got to come up, somehow multiply 3s and or 5s together to get 75. Don't say it, just write it down. If you can come up with the ways to multiply 3s and 5s together to get 75, write that down. How to get 75 by multiplying 3s and 5s together. You can use powers. There's going to be some multiplying in here. You can use powers too if you want. We'll end up getting the same answer. But if you want to use just multiplication, that's fine too. So this is going to be what your homework is like. The whole trick to these problems in your homework is trying to find the right combination of factors or powers to come up with the number. The whole goal is to use the information we're given to help us come up with the answer for the problem. So, how many of you did not use powers at all? How many of you did not use powers to come up with 75? Okay. How many did use powers? Okay. So what did we get? How'd you come up with 75? What factors did you use? Isabel, what'd you use?
I used 5 squared and then 3.
5 squared and 3. So that would be one thing you could do. So this times 3. Does that equal 75? Okay. How many used that? How many used it flipped around? How many used something else?
I just put 355.
355?
Yeah.
Oh, like
I
this?
just wrote it out longer, yeah.
How many did that?
Same thing.
Okay. Any of those are fine, right? They all equal 75. I don't care which one you use. I used 3 times 5 times 5. Okay. If you use 3 times 5 squared, that's fine. I'll show you how the answer works exactly the same. So I multiply those all together. Now I can separate them using which operation? How do I separate into different logs now? What operation do I use?
Addition?
Addition, yeah. So I just separate using addition. How have you skipped this step and went right to this? Okay. I would encourage you not to do that. Write this one out first. All right. So what is log base 4 of 3?
It is what is it?
0.7925. What is log base 4 of 5? 1.160. So I just plug those in now. So if you would have written this right here, just to show you that it ends up being the same thing. Log base 4 of 3 plus log base 4 of 5 squared. Now what happens to the 2? It comes in front. Okay. So I end up with 0.7925 plus, so instead of having 2 of these like we did, you have 1, but it's multiplied by 2, which is the same thing. So just showing you that you should end up getting the same answer either way. And so there's more than one way to get at that answer, and that's okay. So long as whatever you start off with still equals 75, you're allowed to do that, okay? Any questions about this product property? Like I said, your homework part of the trick is going to be finding the combination. And again, what I was mentioning to you before, since this was log base 4, you always have, if you want to use it, you always have this available for this type of problem, if it works. If it makes sense to need to multiply by 4. You always have that, because this always equals what? When the base and the number are the same, what does it equal? This always equals 1. So you could always use it even if you're not given it in the direction. And in this case, since we were trying, granted, there's no reason to use 4 to get me to 75. But if there was something that had 4 as a factor, then you could use that if you wanted to. You don't have to, but if you wanted to. All right, let's look at the next and last one. What's the last one going to be, you think? Subtraction, which is, so what are we talking about with the, what operation are we talking about before we get to subtracting the powers? Division. So the next one, okay. So I plug them in, add them up. What did you get? Or did you finish yet? All right, add those up and let's see what you get. Okay, a couple. 3.1145, which means 4 to this power equals 75. Now, let's look at it real quick as if you had it as 5 squared. So I'm going to go back. Is the quotient property. The quotient property. And again, this is on page 1109. But essentially, if I have a logarithm and it is a fraction or a division problem, you can separate by subtracting. Log A minus log B. What's really important here is the numerator comes first and the denominator follows the minus sign. It has to be in this order. So like over here, they give us an example, log of 5 over 6. So it's log 5 minus log 6. The numerator comes first, the denominator comes second. Same exact directions. Okay, log base 4. So you could even just put this problem right under where you already started that one, maybe make some space or whatever, because the directions are exactly the same as the last problem. I think you can do this one. Do you want to try it?
Sure.
Try it. So what comes first?
The
The 5. Log base 4 of 5. And then what's second?
the log base 4 of 3.
What am I doing with those?
We are
Subtract. People will make. This is wrong. What I'm writing up here right now is wrong. Please don't do this. I will see people do this. Log base 4 of 5, and then they'll just go minus 3. Or I will see people say log base 4 of 2, because they just go 5 minus 3. Like, all of that is wrong. You can't do that. The only way you can separate is, and again, notice, I separate and have 2 different logs. Log is on both of them. So please don't do that. All right, that's the first part of your homework today. The second part of your homework is actually, okay? How many had this? Okay, good. That's all you got to do. So then I just plug in. Okay, log base 4 of 5 is 1.160. Log base 4 of 3 is 0.7925. Mistake. And then I subtract. Final answer, 0.3685, which means 4 to this power equals 5/3. Now, something I want you to pay really close attention to about what I'm going to say right now. This number can be negative. Okay, we can have negative powers. So if you end up going through all of this and you end up with a negative, that's okay. There's nothing wrong with that. Actually, that involving equations. And what we're going to do now is work it all backwards. So in the first part of the problems that you're going to do today, you're going to separate things using powers and create more logs. In the equations, we're going to condense them down using the power. So we're going to the properties, excuse me. We're going to use the properties backwards to try to get movie theater B. We're going to try to create an equation such that we're in movie theater B. Okay? And I will warn you, there has to be logs on both sides in order to go into movie theater B. If there's only a log on one side, we are only in movie theater A. But most of the time, this is what we want to do. In this case, I want it to get it to log equals log, and then I can cancel the logs and just solve. That is our goal. So, let's talk about this left-hand side. Again, think about using the properties backwards. What's going to happen to this 2? Where's it going to go? Yeah, it's going to go back in on the x. So essentially, it's going to come back as a power. I want to fix that line. It's going to be the power right there. So it's going to be x squared, right? Okay. What does this plus tell me I'm going to have to do? Multiply. Multiply 27 and 3. Okay. So I'm going to end up multiplying those 2 together. Any questions about that?
No.
So here's what I've got. Log base 7 of x squared. So again, we just move that 2 in. And then log base 7 of 81, we multiplied 27 times 3. So I got it. I got log equals log. So now I can just cancel the logs out. X squared equals 81. How do I solve that? Square root both sides. And whenever I square root both sides, I have to do what? What? Yeah, plus or minus. You got to have plus or minus anytime you square root both sides. So I get x equals plus or minus 9. Now you got to check. Now the check, again, you don't necessarily have to show me anything for the check. But you have to make sure that both values don't create a situation where we no longer meet the conditions. So for example, the only place I'm plugging in is right here. And I plug 9 in here. Do I have a problem? Does it create a problem if this is 9? No. Does it create a problem if this is negative 9? One of those. It's either yes or no.
Yes.
Can this number next to the log be negative?
No.
No. So if So negative 9 does create a problem.
So it's just so X.
So I got to throw the negative 9 out. Okay, so my only solution is x equals 9. That's the extent of the check. And you can do all that in your head if you want. If you want to write it out, fine. But I'm giving you permission to do that in your head. But don't leave the problem without doing the check. Because oftentimes you're going to throw some numbers out. Now, and also don't think, oh, always throw the negative one out. Because if this would have been negative x, and x was negative, negative x is positive, right? So it could have been okay. You just have to watch out. So that's why I just say, just check it real quick and you're good. Because again, this still has to always be positive. All right, one more. Any questions on that before we look at the last one? All right, here's the last one. Now, in my other classes, I have had kids that move stuff around first. I don't think you have to move anything around. Yeah. My goal for you is to use the fewest amount of steps as possible, believe it or not. So moving things around creates more steps. If you really want to do that, you can, but you don't have to. Okay. The right-hand side here is fine. So notice I have logs on both sides, so I want to get it to log equals log. If there was only a log on one of the sides and not on the other, then you'd have to rewrite in exponential form, movie theater A, okay? So this right-hand side is fine. There's nothing to do here. What operation am I going to use on the left? Division. How do you know that? It's because subtraction tells us to use division. So what it should look like is this. Log base 4, 48 over n. How many had that? Good. Log base 4 of 6. So what does this mean? What does this tell us? What does this let us know?
48 over n equals 6.
Correct. 48 over n equals 6. So what's n? What? 48 divided by what equals 6? 8. Now the other thing you could do, if you couldn't sort of think of it in your head, do you know you can do this? It's like you can just swap those. Did you know you could do that? It's just like a proportion. You can just swap them. Which, of course, what is 48 divided by 6? Still 8. You still were right. Okay. When I plug 8 in here, do I have a problem? Nope, it's positive, so we're good. That's it. Okay? General questions.